Okay, we're a couple of minutes in. I'm sure we're going to see some more people join us, but we're going to get rolling for respect to everybody's time. So welcome to everybody. My name is Terry Adamson. I'm the technical director with Fenestration Canada. We're going to do a session today. Can you hear me now? Talking about acoustic testing and performance. I want to recognize UL Solutions as our sponsor for today's Tech Talk. And we certainly appreciate our sponsors. So in Canada, there currently is no code requirements for acoustic performance and testing of windows and doors. And over the last several months, I've really had an uptick in inquiries from our industry here in Canada, as there appears to be quite an increase in project specifications that include requirements for sound control, that includes sound transmission ratings for fenestration. The growth and density within our cities is increasing, as everybody knows. The need to introduce limitations on sound intrusion into buildings is growing. This has led to an increase in window and door manufacturers looking to test labs for guidance. Currently, there are a few, if any, test labs within Canada that do this kind of testing. So this requires products and testing to be done in locations, typically in the US, such as the QAI facility in Miami, Florida. So today with me, I'd like to introduce Michael Tostowaryk from QAI Burnaby and Jose Sanchez from Miami, Florida. So Mike, why don't you tell us a little bit about yourself and QAI here in Burnaby?
Thank you, Terry. I'm a door and window specialist here at QAI in Burnaby. I cover basically Western Canada and also into the United States as well. Yeah, I've been in the window industry for a number of years, and the first time really I heard about sound testing was about 7 years ago. That's the first time it had popped up when I had heard of it. Since then, I know we've had a lot of requests for that. So it's certainly something that's growing in popularity of especially in the high density cities.
Okay, thanks, Mike. And Jose from Miami, Florida, beautiful Miami. Why don't you tell us a little about yourself down in Miami and what you're doing at the QAI lab there?
Yes, hi, thank you, Terry. So yes, my name is Jose Sanchez. I work for QAI Laboratories. I was employed for Fenestration Testing Laboratory for 18 years before it was acquired by QAI in 2019. My responsibilities including overseeing internal operations, helping to build a strong customer relationship, maximizing the company's operating performance, and helping to achieve the company's financial goals. I've been working for QAI Laboratories now for 4 years as operation manager for our Miami location. My responsibilities include overseeing internal operations, maintaining the lab's accreditation certifications, and helping to achieve the company's financial goals.
Great, thank you very much. Okay, so Jose's got a bit of a presentation for us on acoustic testing. So I've opened up the share for you there. So if you can share your screen, we'll go through that.
Sure.
While he's doing that, anybody attending, you can use the Q&A if you have any questions during this, and we'll get the questions towards the end of the session. Oh, we lost your screen again.
Yeah, I'm sorry. Okay, hello everyone again. Thank you for attending this presentation, and I hope that I can provide you with helpful information about acoustical testing and test methods. Today, I plan to discuss the test methods used for acoustical testing, inspection, testing process, steps, and building code requirements. QAI uses the recognized AST and test methods to classify the product sound transmission class, STC and/or outdoor-indoor transmission class, OITC ratings. Ratings are given depending on the product's use. So for example, exterior windows, doors, and skylights and glaze wall sections are given an STC rating. Interior windows, doors, and glaze wall sections are given an STC rating. STC is a single number rating used to determine how sound is blocked from going through a product. And OITC is a single number rating used to rate the effectiveness of a building facade elements in reducing the transportation noise intrusion. For windows, doors, skylights, and glaze wall sections, QAI follows the ASTME 1425. To provide a uniform rating system, Manufacturers follow the test specimen size indicated in the ASTM E1425 document. Each product type has a specified test size, and the slice on the screen shows the test specimen size from the ASTM E1425. There are some cases when the customer deviates from the standard test size because they have been requested by the architect or end user to test a specific assembly size. Products are submitted by the client for testing to meet their requirements. Clients are not required to be on site for testing. However, some choose to be on site to learn about their product performance. Once the product is selected for testing, it is installed into a test opening of a filler wall that has a higher sound transmission loss than expected for the specimen being tested. A foam isolator pad is placed on the bottom of the test opening to support the test specimen and isolate it from the opening. A duct seal compound is used to seal the perimeter of the test specimen frame to the test opening on both sides. The use of specific sealing compound to achieve a given sound rating could affect operating force of sliding windows and doors. Therefore, the force to open, close is measured and reported. The CSA 101 IS2 A440 document provides operating force acceptance criteria for products on their performance class. Latching force can affect the compression of seals and have an effect on the acoustical performance. Therefore, the force to latch is also measured and reported. Air leakage is performed per ASTM 283 test method and reported at both test pressures 75 and 300 Pascal. Sound transmission loss is performed per ASTM E90 test method, so FTC and OITC ratings can be calculated. Each test run takes approximately 5 to 10 minutes to complete. At this time, FTC and OITC ratings can only be achieved by a physical test. Some options a manufacturer has to achieve better performance ratings are multiple glazing options. This includes glazing glass thickness and or gap width, different weather stripping and or seals, and insulated frames, example, foam-filled frame cavities. There are several contributing factors for not achieving the expected FTC and or OITC ratings. Selecting the appropriate glass configuration with a rating higher than the expected value is recommended. Some of the bigger glass suppliers have FTC, OITC published data made available on their internet. Product operability and air tightness can also influence the test results. Products with a higher air leakage can perform worse than those with a lower air leakage. Most solid frames perform better than hollow frames. To combat this, some hollow frame cavity manufacturers typically fill their frame cavities with foam. This is also good for energy efficient. Here is a list of typical products we test: windows, doors, skylights, glazed wall sections, partitions, and wall systems. At this time, QAI only offers acoustical testing at our Miami location, though this can change in the future with an increase of demand. FTC and or OITC ratings are not required by building codes. This is typically industry driven by either architects or end user to provide comfort from outside noise. Job specifications can reference required FTC and or ITC ratings, as Terry mentioned, and product certification is not required, though it is made available by QAI Laboratories and some other labs. Again, thanks a lot for your interest and attendance on this presentation. Please send an email and info@qai.org or myself to receive a summary of our presentation and technical information regarding acoustic testing. Now I'll open the floor for questions. Thanks a lot.
Thanks, Jose. Okay, a short presentation, but you know what? You actually answered a number of my questions already. So I might just try to expand a bit on a few of the points that you made. You mentioned that there are no code requirements in the US, and that's the same as in Canada. And the requirement for this testing is being driven by specific project specifiers or architects, et cetera, right? So there are no actual code requirements driving this work, correct?
That is correct. It's mostly being driven by either the architect or end user. Some job specifications are being carried over from project to project, and that's probably where it's coming from.
Okay. Do you see a sort of a typical situation where the sound performance is being driven? Like, are we talking about, near airports or, in dense areas of cities, or is it just driven by what maybe an architect or a specifier wants to do on their specific project?
Yeah, I've seen it. I've seen it for projects that are close to airports and also schools.
Schools. Okay. Okay. That's interesting. Okay. So I don't believe there's any facilities in Canada doing this. And you mentioned that QAI Florida is the only QAI lab doing it. Was that correct?
That is correct. At this time, Miami is the only location that has an acoustical facility.
Okay. You talked about the standards. You said a typical test takes about 5 minutes. And you mentioned that some manufacturers would attend testing and maybe some wouldn't. I'm just wondering, for a manufacturer that wants to attend, I mean, is there anything that they can actually do that would impact or improve a result once the product's there?
So they do have the ability to add pads or gaskets to their assemblies to try to achieve better air leakage results or sound transmission ratings.
Okay, so if a product goes through a test and the manufacturer has a representative there, they could potentially technically make a change to that product to get a better number in another test.
Yes, we have some clients on site sometimes where they're changing their weather seals for different ratings. The weather seals could either be acoustical rated or just standard seals that they want to try to achieve some type of rating on.
Okay. Could it go so far as to, if you had a product in the test chamber that was dual glazed, for example, could they change the glass in that to a triple and get 2 test reports out of the same product?
They could use the same frame if we could replace the sash, yes.
Okay, okay, great. So once you have data and you've done some testing, are you able to extrapolate that data based on other data? Like you mentioned that some IGU suppliers have values for specific configurations of glazing. So if a manufacturer tested a product that had X glazing in it and he achieved this OITC number, could you use data based on an IGU supplier's test data to extrapolate so that you wouldn't have to actually do another physical test? Is that possible or no?
If the IG configuration composition is the same, you should produce or see similar results. So you should be able to do that. As long as the configuration of glass does not change from one supplier to another, that should be okay to do.
Okay. Are the reports, I think you said that there is a certification available with that data. Does a manufacturer have to have a certification process to use the data, or can you simply get, test reports that, like, I'm trying to understand the certification process and if it's required?
So at this time, certification is not required. Our customers use our test reports to submit it to the either architect or building official that's requiring this test to be conducted. So they use the test reports, a test report basis.
Okay, great. Okay, I'm going to stop my questions, and we have a number of questions already from the attendees. So Aaron is asking if they can get your presentation sent to them. Is that possible? Do you?
That should be, like, yes, that's possible.
So if you were to provide it to me, I could maybe put it up on our website and we can make it available to people. Just making myself a quick note here. So we'll work on getting you that. Okay, so Dave Goldsmith on Applied Gem, he says in British Columbia, they're trying to meet thermal simulation requirements as well as OITC requirements. The thermal requirements call for triple glazing. Is there a glazing solution in triple glaze that offers high OITC numbers? And he's suggesting 34. Are you familiar with, you know, and I realize that the glazing is only one component of the final result. But just having triple glazed units is somewhat problematic because of some limitations in overall IG thicknesses, et cetera. Some, you know, are you seeing good results like a 34 in triple glazed PVC products? Is what I think Dave's probably talking about.
So we haven't tested many triple glazed units for STC OITC. We are seeing a 34 on some dual configurations, but that will all depend on the glass thickness and gap width.
Yeah. Okay. Okay. So Anton from Central Windows here in BC has the same question I posed, but maybe we can dig a little bit deeper into it because I think it's worthwhile. So you have 2 or 3 tests of a product with different glass makeups. Is there a way to extrapolate those ratings that would be in between those values? So if, let's say, for example, you had 2 tests done and you were using triple glazing and you were using 4 mil, 4 mil, 4 mil, and you had another test with 6 mil, 6 mil, 6 mil, could you extrapolate and give me a number for 5 mil, 5 mil, 5 mil? I realize that's really simplistic, but is that even possible?
I'm pretty confident that a trend line could be developed and extrapolation could be done. We have never attempted it at QAI, but I'm confident that it could be done.
Great, great. That would save some work for sure. Okay, so Anton's also asking, is there any field processes for sound testing out there? Anything that QAI can do or that you're aware of where sound testing is being done for products in the field?
ASTM does have a test method for field testing of acoustical products. At this time, QAI does not have the equipment or capability to perform such tests, but I am aware of some other labs out there that do offer that service.
Okay, great. It's good to know. Are you seeing, are manufacturers being successful? Like, are they coming in with a target in mind and a design and getting the numbers that they want, or are you seeing it as a much bigger struggle with current window and door systems trying to get to the numbers that specifiers are asking for?
Over the years, I've seen clients achieve the targets that they're achieving, that they're looking for. They've gained knowledge. There's enough information on glass configurations and STC OITC ratings that they have a better understanding and idea of what kind of materials and glass options to use to achieve those ratings. Okay,
great. You mentioned that many of the IG glass suppliers have values on their sealed units only. I'm just wondering if you have sort of an indication of, okay, if the sealed unit only is getting pick a number, 38, let's say, what is the sort of typical variation once you put that into a frame? Let's say we'll use PVC, for example, a picture window frame that is a non-draining frame that does not have drainage pass through the frame to the interior. Do you have any indication of what a manufacturer should expect to hit based on a value that an IG supplier already has?
So on a picture window, they're typically hitting those same targets, maybe a couple decibels, dBs below that. On a operable system, because you have air intrusion, you're seeing those results come down a bit, not by much, but they will be reduced a bit.
Okay, so a manufacturer looking at those values from a sealed unit supplier, they should feel reasonably confident to get, like you say, within a couple of points in a picture window system, non-draining. Is that how I understand that
Correct.
response? Yeah. Okay, that's good
That
to
is
know.
correct.
Gives the manufacturer an indication of where they can get to based on an IG supplier's numbers. Are you seeing Lamy glass being a really significant component in getting to the targets? I know that some of the sound testing that I did in my former life, we actually found that Lamy, like a 6mm Lamy with an 015 interlayer, was not really getting a much different number than using just a single piece of 6mm as a replacement for that component. What's the use of Lamy glass, and does the interlayers make a big difference? What's your experience with Lamy?
So interlayers do make a difference. Some have more damping than others. I do know that some interlayer manufacturer suppliers now have acoustic rated interlayers that provide a couple points more than your standard interlayer film.
Okay, that's great to know. Probably fairly simplistic, but in your experience, what do which products perform the best, if you like? I know that you talked about products with cavities, typically adding some foam filling is going to improve that. Products that don't have drainage systems that penetrate to the interior. What about, are you seeing significant differences when you look at different substrates of frames, like the wood products, maybe aluminum, fiberglass systems? Do you see a trend of products that perform better in sound testing?
More so commercial products that have deeper and bigger frames. Wood frame manufacturers with the solid frames. I've seen those perform slightly better than hollow cavity from manufacturers.
Okay, good. I know we talked about the availability of test labs, and Miami being the QAI lab that's available. Do you guys partner? This might be for Michael. Do you guys partner with other labs to facilitate testing in other regions? And for example, the Canadian West Coast. I know that some of the work that I did in the past, I was having to send products to California, places like that. I'm just wondering if you work with other labs in regional areas to support manufacturers there, so they don't have to ship products to Miami, for example.
Here in outside of Vancouver in Tacoma, Washington, which is just south of Seattle, so fairly close to us, there's a company called NWAA Labs, and they do sound testing. So I've referred a lot of our clients to them. Otherwise, their options are ship it down to California or Texas or Miami in our case.
Yeah, expensive proposition when you're
Yeah.
in
Yes,
Canadian
it
West
is.
or in East.
Yeah. And the nice,
okay, so I've got another. Go ahead.
The nice thing about Tacoma for people on the West Coast is it's drivable, so they can send somebody down to the lab to witness testing, whereas they're not having to fly, all the way to California and hotels.
Right. Yeah. Jose, I don't want to take work away from you, but Miami's a long way from Vancouver. Okay, so another question from Dave at Plygym. He says, oh, this is a good one, Dave. What's your best guess at a triple glazed unit with a high OITC, a layer of 6mm Lamy and other lights, standard thickness, I'm going to say 3 or 4 mil. Again, that data is probably available through IG suppliers that have done this work and that have a range of glazing designs in their units. Do you have a number that you would throw at that as an OITC number? Triple glazed, a layer of 6mm Lamy, and a couple of lights of let's say 4 mil.
Yeah, if I threw a number, it'll probably be a bit misleading. I don't have that programmed in my head. Sorry.
Fair enough. I know that one of the challenges that we experience is that anytime you start adding components like 6 mil or Lamy into the makeup of a unit, reducing the air thicknesses in those cavities becomes really detrimental. And maybe a better question is, what's your experience as you reduce those air cavities and the impact to the result? Do you sort of have a sweet spot of a cavity that gets good value? I know that, again, that's kind of a difficult one to answer, but do you see a cavity space maybe that really is detrimental to getting a decent number?
I've seen the half-inch gap perform pretty well. When you start getting into triple glazed units, your gap starts being reduced slightly. So quarter inch doesn't perform that well. You would need very thick glass on the opposite, on both sides, to get good ratings. But for the most part, 3/8 to half inch is a typical gap width that performs good with good ratings.
Okay. And along with that, I mean, talking about IG design, my experience, and I think this is probably, pretty common knowledge, but mixing up the glass thicknesses in a unit are really critical to getting better performance. Is that a fair statement?
It is. Yes, it is.
Yeah. Okay. Any thoughts about, the variation of those thicknesses? Like, for example, if we only vary those thicknesses by a millimeter, let's say 4 mil and 5 mil, will I get better results if I go 3 mil and 5 mil with a larger variance in those thicknesses of glass panes?
You'll get a slightly better result. Just keep your thicker glass to the exterior of the product if possible.
Okay. Okay. That's good to know. Okay. So another question here. Would you expect any difference in acoustic isolation performance between glass from different suppliers? For example, would you expect to see any discernible difference between the performance of a 3 mil glass supplied by, and I'm going to use company X, compared to the same light of 3 mil from company Y?
I have not seen any difference. They should perform almost very similar.
Okay. And then, so Anton, we kind of touched on this, but Anton's asking, what is better, quote unquote, thicker glass or larger airspace?
Thicker glass.
Thicker glass. And again, mixing up those thicknesses of glass is pretty key to getting good numbers, correct?
Correct.
Okay. Everything is spec driven pretty much. Again, no code requirements. Keys to success. I think we touched on a little bit of that. Are you seeing, up here in the Great White North, we're starting to see an increase in frame depths to accommodate the energy performance requirements that we're faced with. I'm not sure that you see the same sort of trend in the southern U.S. Certainly, I think it's probably a reasonable assumption that the deeper the frame, the more cavities that you have, if it's a PVC or a cavitied frame, you should see better performance. Is that? I mean, that sounds reasonable, but is that a fair assumption?
I would suspect a deeper frame would produce better results. Yes.
Okay. Spacer systems. There's a wide range, of course, of different systems. Be it metal, I think there's probably still aluminum spacer systems out there, stainless steel, lots of silicone foam spacer systems available on the market now. Again, I'm going to assume that a foam system, be it a silicone foam or any of those systems that are out there, are going to improve your acoustic performance. But do you have any insight or thoughts about how much of an impact going from a metal, aluminum, or steel spacer system to a foam or butyl spacer system? Is it a key component that you need to look at to get really good numbers, or does it not have a lot of impact being right at the edge and not a major area of the product?
So with the spacer composition being close to the edge of the glass, it really doesn't have any major factors in the rating itself.
Okay, that really surprises me, but that's great to know. There'll be some people happy to hear that. Okay, any other questions? I got one more here. So Scott over at Truth Amesbury, or maybe Amesbury Truth, I guess. Does tempering the glass have any positive or negative effect on ratings? That's a great question, Scott.
No, we've done testing on tempered, annealed, and heat strengthened glass, and we achieved the same results on every different composition of glass.
Okay, great, good to know. Okay, so that's it for my questions. That was great. Some good information there. Hopefully people picked up a little bit of useful information. Just any more questions from the attendees? Going once, going twice. All right. Jose and Michael, I want to thank you guys very much. I really appreciate your getting online here with me and share a bit of insight into what's happening in the world of acoustic testing and certainly the growth of it. I think we're going to see it become a much bigger challenge for our industry, and particularly with our industry as we move towards more and more energy efficiency. That seems to be a challenge, certainly in Canada, where the energy targets are moving quickly and becoming more challenging into triple glazing, triple glazing with specs of, interesting glass configurations that might make the acoustic performance a much bigger challenge. So really appreciate you guys' time. Thanks to QAI for allowing you guys to spend a bit of time with me today. And of course, I want to thank UL Solutions, our sponsor for today's session. So Mike, Jose, thank you very much. Appreciate your time. Last words?
Oh, just thank you very much for having us. We enjoyed it.
All right.
Yeah, thank you very much.
Jose, Mike, thank you again. And thanks for everybody for joining me. And watch for the next Tech Talks coming in June. It's going to be a good one. So watch your emails. Thank you, everybody. Have a great day and talk to you soon. Thanks, guys.